Hello everyone, welcome back to the Gate Engineering online learning classes. In this video, we will talk about parallel RLC circuit and we'll discuss one numerical problem based on this topic. The circuit diagram you can see which is nothing but a parallel RLC circuit because resistor, inductor and capacitor all are connected in the parallel and the voltage source is applied across the circuit is called applied voltage source Vs and current flowing because of the applied voltage source is Is. The current through the resistor is IR, current through the inductor is IL, current through the capacitor is IC, and all the components are connected in the parallel RLC circuit. So this circuit is called parallel RLC circuit. And here we can see the voltage across all the components are same. Therefore, the voltage across the resistor is VR, voltage across the inductor is VL, voltage across capacitor is VC, and all the voltages are nothing but same as the voltage Vs. So Vs is equal to VR is equal to VL, which is also equal to VC, because all the components are connected in parallel to the applied voltage source. And here current is dividing at a node A, but here we can't apply the nodal analysis as Is is equal to IR plus IL plus IC. We can't apply in this manner because the resistor, inductor and capacitor all are not in the same phase. Resistor, inductor and capacitor all are in different phase. It means voltage and current are in the same phase in the resistor, but voltage and current are not same in the inductor and capacitor. In the inductor, voltage leads by angle 90° from current, and in capacitor, voltage lags by an angle 90° from current in the capacitor. So if the right side we see the phasor diagram, in the phasor diagram, we are taking a voltage which is nothing but the voltage source Vs because the same voltage across the resistor, inductor and capacitor. And we know we know the current and the voltage both are in same phase in the resistor. Therefore, current and voltage both are plotted on the same direction at same axis. And voltage leads by angle 90° from current. Therefore, current is lagging by angle 90°. So voltage is plotted at 0°, current is plotting at minus 90° axis. And in the capacitor, current leads by angle 90° from voltage. Therefore, current is plotted at the plus 90° axis. And if we see this resultant phasor diagram and IL minus IC, this height is nothing but the IL minus IC. I assume IL is the greater than IC. Therefore, this height is IL minus IC. It indicated here. This distance, this base is IR. Therefore, this hypotenuse is the IS. So this height is IL minus IC. So if we redraw this phasor diagram, it is called as current phasor diagram. If I redraw this phasor diagram, this will be like this. So this height is IL minus IC in the fourth quadrant. This length of this branch is IR and this hypotenuse is IS. And the phase angle between IR and IS is the phi. So this is phase angle is power factor angle. So by this triangle, we can conclude by using Pythagoras theorem, IS is equal to square root of IR square plus IL minus IC whole square. So if I write this equation again with the help of Pythagoras theorem, Is is the source current which is equal to square root of IR square plus IL minus IC whole square. So in this kind of a circuit, we can ask to find the voltage across in such kind of the questions we can ask to find the impedance of the network. We can ask find the current through each component. So current through the resistor is IR, current through inductor is IL, current through capacitor is IC, and impedance with the parallel combination of R, L, and C. So we got the current equation which is 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 equal to square root of IR square plus IL minus IC whole square. Is is nothing but the voltage divided by Z because this voltage is the Vs. So Is is the applied voltage divided by the Z. This equivalent of RLC will be the impedance. And IR is the current through the resistor, so it will be V divided by R whole square. IL will be VL divided by XL and IC will be VL divided by X0. Because IL is the current through the inductor, that is VL divided by XL. IC is the current through capacitor, that is VC divided by XC. So all the resistor voltages are the same. VR is equal to VL is equal to VC, which is equal to VS. So voltage is common, and we will get the equation V divided by Z, which is equal to square root of 1 divided by R square plus 1 divided by XL minus 1 divided by XC whole square. From here we use the cancel out, and current and impedance is 1 divided by Z. Reciprocal of the impedance is 1 divided by Z, which is equal to 1 divided by R square plus 1 divided by XL minus 1 divided by XC whole square. So to calculate the impedance, we can use this formula, and resistor, inductor, and capacitance value will be given in the numerical problem, and we can use this formula to find out the impedance and currents. So let me see the numerical problem now without doing any further delay. So this is the example, and in this example we have given a value of the resistor which is 50 ohm. We have given inductor 20 millihenry and capacitor for 5 microfarad. All are connected in the parallel across a voltage source of 50 volt and 100 hertz frequency. So we have given this information that resistor is 50 ohm, inductor is 20 millihenry, capacitor is 5 microfarad, and voltage source is 50 volt with 100 hertz frequency. All are connected in the parallel. In this question, we need to find the total current, that is IS. We need to find the total current IS. We need to find the current in each branch, that is IR, IL, and IC. And total impedance also we need to find. We need to find total impedance of the circuit, and we also need to find the phase angle, and we need to draw the current triangle for the circuit. So how do we start? We have given the resistor, inductor, and capacitor. First of all, we'll find out the impedance. That impedance is nothing but the impedance formula, that is 1 divided by square root of 1 divided by R square plus 1 divided by XL minus 1 divided by XC whole square. That we are getting from this formula, which is 1 divided by Z is equal to square root of 1 divided by R square plus 1 divided by XL minus 1 divided by XC whole square. So here we substitute the resistor and XL and XC value. But what is XL, what is XC? We have given the inductor and capacitor, but XL and XC we can calculate by using some formula, that is XL is equal to 2 pi FL, where F is 100 hertz given in the question, L is 20 millihenry. So it is 2 pi into 100 into 20 millihenry, that is 0.02, and this is XL is 12.56 ohm. XL is called inductive reactance. Now we need to find the XC, that is the capacitive reactance, which is 1 divided by 2 pi FC. So here 1 divided by 2 pi multiply with 50, multiply with the 100 because frequency is 100. Capacitor is 5 microfarad, so it is 5 into 10 to the power minus 6. If we simplify it, we are getting the value of XC, that is 318.47 ohm. So this is the capacitive reactance. Now we know the value of resistor, we know the value of XL, we know the value of XC. We can easily find out the impedance, that is equal to 1 divided by square root of 1 divided by resistor, which is given in the question of 50 ohm, 1 divided by 50 square plus 1 divided by XL. XL is 12.56 and XC is 318.47. So 12.56 minus 1 divided by 318.47, that is the XC whole square. If we simplify it, you can use the calculator to simplification of this expression. You will get the impedance value, that is 12.7 ohm. The impedance is Z, which is 12.7 ohm. Now we need to find the current in each branch and overall current. So total current drawn from the supply is VZ divided V divided by Z. So IS is the current, total current. Total current is 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 equal to VS divided by Z, where VS is 50 volts and Z is 12.7. So it is 50 divided by 12.7, and from here current is 3.9 ampere. Now we can also calculate the IR. IR is the current through the resistor, that is V divided by R. V is 50 and resistor value is also 50. So from here IR is 1 ampere. To calculate the current through the inductor, that is V divided by XL. V is 50. XL is calculated, which is 12.56. And if you simplify it, you will get the value, that is 3.96 ampere. For calculation of IC, it will be V divided by XC, and V is again 50, and capacitive reactance is 318.47, which is equal to 0.16 ampere. After calculation of all these parameters, we need to find the phasor diagram and power factor angle. So we know the current phasor diagram is this is the IR, height is IL minus IC, and this is the IS, and this is the phase angle phi that we need to calculate for the power factor or power factor angle. IR is 1 ampere, so this is 1 ampere. IL minus IC, as we can see, IL is greater, IC is less than. So 3.96 minus 0.16, we will get the IL minus IC, which is equal to 3.80. So IL minus IC is 3.80 and IS is 3.9. So from here we can find this is the current phasor diagram. This is the current phasor diagram. You can easily draw the current phasor diagram for parallel RLC circuit. In the previous video, we have seen the voltage phasor diagram for the series RLC circuit that you can see in the top corner of this video. Current phasor diagram of parallel RLC circuit. And to find out the power factor is nothing but cos phi that you can calculate by base divided by hypotenuse, that is IR divided by IS, and it is 1 divided by 3.9. You will get the power factor cos phi, and for power factor angle is phi is equal to cos inverse 1 divided by 3.9, which is equal to 75.3 degree. So in this questions, we asked to find the current drawn from the supply, current through each branch, total impedance, circuit, total impedance of the circuit, and phase angle. Also, it was asked to find the current triangular diagram. So we calculated first impedance. For the calculation of impedance, we used we find out the XL and XC. We find out the XL and XC for find out the impedance. And after calculation of impedance, we find out the current, that is voltage divided by impedance. So IS is V divided by Z, IR is V divided by R, IL is V divided by XL, and IC is V divided by XC. After calculation of all the currents, we find out the phasor diagram, that is IR is the base, IL minus IC is the height, and IS is the hypotenuse, and this angle is the phase phi. So it is this phase phi is the power factor angle, and power factor is cos phi here. So this is the overall summary of this numerical problem. So we have seen one numerical problem in the parallel RLC circuit, and we have seen the discussion on this. Thank you.